Okay, so this uh, video is on 10.3, which is hyperbolas. So if you remember, we kind of are showing you here, a hyperbola is formed when you have your double cone, your double cones, like one is on top of each other, and you take a vertical slice. So if we look at this, by the end of this, hopefully this video, you're going to be able to use and determine the standard and the general forms of this equation of a hyperbola. And then you can use that to graph a hyperbola. So we're going to start with, okay, let's look at the standard form of a hyperbola. Now, a hyperbola is really, so far, let me go back here. We're going to have a discussion here. I don't know if I have an ellipse I can draw. Oh, I have an ellipse. Great. So if I have an ellipse here. All right, so there's my ellipse. A hyperbola is where you say, okay, if I was able to cut this ellipse in half, and I had this figure here, all right, and I took this half of it, and really what I do, and I don't know if I could do this, I'm going to give it a try. If I was able to take this half, what I do is I'm really going to flip it left or right. So if I just flipped it and I turned it out, all right, same thing with this one. If I could just flip it and you kind of bring it outside like that, that is what we're talking about with a hyperbola. A hyperbola looks like that. Now sometimes your hyperbola is like this, because we know sometimes our parabolas are the other direction. So sometimes your hyperbola is like this. Sometimes your hyperbola. So now let's talk about exactly what is needed to graph a hyperbola. So we have a hyperbola. It's a lot like the equation that we used with ellipses. And when we talked about this, it's just that turned inside out. The biggest difference is we have a subtraction sign here instead of an addition sign. In fact, that's the only difference, okay? One of the things, though, because of that subtraction sign, here you do see them switched around more. Like usually we always see the x squared, and you're going to see y squared coming first and the x coming second. And I'll show you some examples of that in a bit. What we kind of do is, it's a lot about this box that you see right here. It's going to be a lot about making our box and using that to make our hyperbola. So we're going to have our center point, just like we found our center point with our ellipse. And then from the center point, we're going to use it to figure out our B going up and down, and our A going to the right and to the left, okay? Now, the A, the bigger value, and actually here it's the one that starts off where your x squared is positive, that's going to be the vertices, to the right or the left of your center point is going to be your vertices for your hyperbola, okay? So that's actually the starting point for a hyperbola. It's important to find your minor axes here too, because it's part of making this box that you see there. And then what we do is we make that box, and then we draw the diagonals in. And those diagonals actually turn out to be asymptotes. So we extend the diagonals, and those become the asymptotes for our hyperbola. So here we would know where to start it from this major vertex, and then it always kind of curves toward the asymptotes. And so we have this major vertex that starts, and it curves towards the asymptote. So in your book, it does a good job of showing the two different equations. So this is what I was talking about. Sometimes you'll see that the x starts first. Sometimes you'll see that the y starts first. And it depends on which one is the major and which one is the minor axis. Now, I've had some students just have to have both pictures in their notes, okay? And I know it can be hard to say, where does it curve? Does it curve right and left or up and down? Where are my two kind of curves or my two parabolas? Where do they exist? I kind of remember when it's x squared is positive, it's going to be right and left, kind of on, I see it like left and right on the x-axis. When the y squared is positive, I see it on the y-axis, up and down, all right? And for a long time, I've been thinking x is left and right and y is up and down. You're going to have to find your own way to kind of memorize that. So let's look at some examples. When we are graphing a hyperbola, and it's given to us in standard form, there's a couple things we need. We need the center. Okay, well the center here is at -4. oops, and I do this all the time. I apologize, it's not -4. This one is going to be, I kind of have in my head a visual of what it's going to look like. This one in my head, I know it's going to look like that. It's going to be the up and down because the y is positive and the x is negative. So the center here is at 2, -4. So it's not necessarily in the order, it's what's connected to the x and what's connected to the y. So my center is at 2, -4. My x value, in this case my a, is going to be 6. My b is going to be 25. Okay, and we'll talk about the foci here in a minute because it's nice to know the foci, but it's not used a lot necessarily for the graphing part. Let's just talk about graphing it, although we're going to need to know the foci. So our vertices are really, for this one, only going to be taking plus or minus your a. All right. Where do we add or subtract it to? Well, it depends if the a is under your y value or your x value. So we're going to be taking plus or value the a with the y value. So our vertices would be at 2, and it'd be at -4 plus or minus 6. So our vertices are going to be at 2, 2 for -4 plus 6, and at 2, -8 for -4 minus 6. Okay, so let's get to graphing this. Let's start with the center at 2, 1, 2, 3, 4. Here's 2, 4. All right, in my y direction, up and down, I'm going to go the square root of 36, or 6 units. 1, 2, 3, 4, 5, 6. That's my upper limit. 1, 2, 3, 4, 5, 6. That's my lower limit, and it turns into my vertices. Left and right, with my x, I'm going to go the square root of 5, or square root of 25, excuse me, which is 5. 1, 2, 3, 4, 5. Limit here, 1, 2, 3, 4, 5. All right, and then what I do is I draw my box. So notice how I'm just kind of completing that as a box. And then it's really helpful if you draw in your asymptotes. In a minute, we're going to be talking about how do we figure out these asymptotes. So there's the asymptotes drawn. And then this graph would just start here at your vertices. It starts at the longer end, or where the whatever is positive, and here in case it's y, and it goes toward your asymptotes. So here's my vertice, and it goes toward my asymptotes. Okay? Now, in the directions originally, they said, what's the foci? We kind of have the vertices already, but we need also the equation of the asymptotes. It's one thing to know how to graph it, but there's other things that we have to learn on how to actually find the asymptotes and find the foci. So now we have to say, what is my foci? I'm going to go back here and remind us. Now, this is another thing I should have mentioned when we were showing this to begin with. Our foci, our c for our foci, is now not a squared minus b squared, but a squared plus b squared. So when we're trying to find that c, that focus here, the two different foci, sorry, I'm going to take here, I'm going to get a different color so I can tell I'm doing something different. I'm going to come over here. I'm going to say my c squared would be my a squared, 36, and I add my b squared, okay? So I have 61. So my c squared is 61. So my c is plus or minus the square root of that 61. So square root of 61, I'm thinking to myself, 8 squared is 64, so it's a little less than 8. So 7, let's say 0.8. So in other words, from the center point, if I go up 1, 2, 3, 4, 5, 6, 7, and a 0.8, I'd be about there. And I'm going to be about there. Well, that's actually what you want for a foci here. It's actually going to be on the inside of your curves, okay? So that would be marking here my foci. And what we did is we're adding this square root of 61 to the y values. So to write them out for my foci is at 2, so this is only about the y values now because the y was positive here. And I'm going to take my -4, and I'm just going to write it as plus or minus the square root of 61. I'm not going to go and estimate or anything. It's okay if you just leave it as plus or minus 61. Our last problem now becomes, how do we write the equation of our asymptotes, these green lines? What do we know about this asymptotes? Well, what we do know is we know a point on the asymptote. And the other thing we know is that we actually know the slope. we know how it goes, how high and how over it goes. Maybe I'll try it in red here. So I'm going to go here, how high and how over. I know this went a height here of 6, and then it went over 5. So I know it has a slope of 6/5. And what we do is we kind of look at point slope form. So if you remember when you were given, you had point slope form. You might not have seen this since geometry. And what we do for this is we go y minus a point, the y point given, and we say it's equal to your slope and x minus the x given. All right? Well, our center point here is not just y1. Our center point is given as hk. So we can kind of replace this, and we can put in here, h here for this, and k here for my y, h and k. So it's like your center point. So here I'm going to have y minus, it was, what was it, my point? I even lost it. It was, oh my goodness, I forgot it already. It was 2, 4. Sorry, I got to write that here. 2, 4 was my center point. So y minus 4 equals the slope. The slope was 6/5, and it's x minus 2. That is how you can leave it. I don't want you to solve it for y. I don't care if it's a pretty equation. Leaving it in that point slope form will be fine. So this m here is usually the b over the a. So a lot of times this is what we have. And then we also have to think, hey, that's just not one green line. Also, this green line it's the other green line, this one that has a downhill. It actually went down 6 and then to the right 5. So what we do is we do this, plus minus. So we consider the positive and the negative, because both lines are very similar to each other, except one goes in a positive direction, one goes in the negative direction. They both do have the same slope. So I'm going to go ahead and pause it here, because when we don't have it in standard form, and here's another way when we're talking about this is how you get the asymptotes. That's from your book as well, and that you might want to put into your notes. But it gets to be a little bit more complicated when we start off and we don't have it in our standard form already, because then we have to go through a lot of work to get it in standard form, and then there's work to figure out what the center is, what the foci and the vertices. So I'm going to go ahead and do that in another video.